will be demonstrating my D flip-flop. So here's my D flip-flop code. As you can see, I created a D, my D input, and my clock input, along with the Q and Q not output. Here, my process is based off the clock. So when the clock event, when there's an event on the clock and the clock is equal to 1, then Q will equal D and Q not will equal not D. So now we're going to go down to the test bench. So with the test bench, you see that I created the D flip-flop and use that as a component. Inputs and outputs. Use signals for the inputs and outputs. So as you can see, it says D, clock, Q, and Q not equal to 0. So now we're going to begin in the process. Clock is going to equal to 0, and then after 40 nanoseconds, clock is going to switch to 1, and then after 40 seconds, it's going to keep going. And with D is going to be 1, and after 80 seconds, D will switch to 0 after 80 seconds, and it will just continuously go. So I'm going to go ahead and compile. As you can see, to compile, 0 fails. Now we're going to simulate. Okay. Well, simulation's already running. But as you can see, here, at the initial start, D is equal to 1, clock is equal to 0. And when the clock changes, Q then becomes 1, as clock is 1. When D goes down to 0, clock goes down to 0, but Q remains 1 up until clock then changes to 1, where Q now becomes 0. And it continues on. Default with an enable and reset. So as you can see, here is my code, my VSL code. So I have my clock, enable, reset, D inputs, and my Q and Q not outputs. Here I start a process that relies on the clock, reset, enable. If reset is equal to 1, then Q equals 0, Q not is equal to 1. Else if there's a clock when on the clock event, and clock event equals 1, and the enable equals 1, then your Q will be equal to D, and the Q not will be equal to not D. And then we're going to go to the test bench, and here, as you can see, I created a component where it holds my D flip-flop enable with reset. Here I created the signals and set them all to 0. And with the port map, you have my clock, enable, reset, D, Q, and Q not. So in this process, you look at the enable and you set the enable equal to 0 for 100 nanoseconds. Then you switch and enable then you switch the enable to 1 for another 100 nanoseconds. While another process, clock is equal to 0, and you wait for 50 seconds, and then clock switches to 1 after another 50 nanoseconds. And then another process, the reset is equal to 0 for 500 nanoseconds. While after that 500 nanoseconds, it switches to 1 for another 500 nanoseconds. And then at the process where you're looking at D starts out as 1 for 150 nanoseconds and switches to 0 for another 150 nanoseconds. So now we're going to go to the wave. We're going to go and compile. As you see, no compile errors. So now you're going to go to simulate, run, and run all. So as you see here, right here at this moment, excuse me, like I said, clock is equal to 0, enable is equal to 0, reset is equal to 0, but D is equal to 1. So on the first clock rise, clock now rises to 1, everything else remains the same. But when the clock falls to 0, D remains equal to 1, enable code then jumps up to 1, and your reset is still 0. After another clock rise, clock is equal to 1, enable is equal to 1, D is now 0, Q is equal to 0 as well, but Q naught is equal to 1. You're going to get here at the fourth clock rise. Now clock is equal to 1, your enable is equal to 1, your reset is equal to 0, so that means your D is equal to 1, your Q is also equal to 1, and your Q naught is equal to 0. And it continues on. JK flip-flop within the synchronous set. So as you can see, I have my code for the JK flip-flop. Have my J, my K set and clock with the Q and Q naught outputs, my inputs and outputs. So in the code, similar process, you know, you have your set, clock, J and K. So when set is equal to 1, then your Q is equal to 1, and your Q naught is equal to 0. And also, you know, on clock event, and when the clock is equal to 1, and your J is equal to 0, and your K is equal to 0, your Q and Q naught will not change. So Q will stay at Q, and Q naught will stay at not Q, which is the opposite of Q. And another if statement as where on the clock event, and if the clock is equal to 1, and J is equal to 0, and K is equal to 1, then you have a reset, which Q stays at Q is now 0, and Q naught is equal to 1. Another if right here on the clock event, clock will equal 1, and if J is equal to 1 and K is equal to 0, then that is your set. So in the set, your Q will equal 1 and your Q naught will equal 0. And then the last if statement, on the clock event and clock is equal to 1 and your J is equal to 1 and your K equals 1, then it will toggle. So Q will now become not Q, and not Q will become Q, and it will just switch back and forth. So we go into the test bench, and as you can see, you know, create a component with my JK flip-flop, created the signals for the outputs and set them all to 0, created the port map to map out my inputs and outputs. So in this first process block, you see that we set the set equal to 0 for 500 nanoseconds, and then we set it to 1 for another 100. And the next process, the clock will start at a 0 for 50 nanoseconds, and then switch to 1 for 50 nanoseconds. And in the process for the J and K, J and K will start at 0 for 100 nanoseconds. J will switch to 0, K will switch to 1 for 100 nanoseconds. Then J will switch to 1 and K will switch to 0 for 100 nanoseconds, followed by J and K both switching to 1 for 100 nanoseconds. So here we'll go and compile all. As you can see, there are no errors. So now we go to simulate, and we start our simulation. Select the test bench, and now here we go. So go down to my waveform, drag and click and drag. So now that we have our inputs over here, we're going to go to simulate, run, off. See, it's running. Let's grab this and bring it all the way to the beginning. So from here, you can see at the beginning, you know, all of our inputs are started at 0 as instructed. But then you see Q and Q naught are undefined because they have no values. So when you get here, you see that, you know, your clock is on, your J is at 0, and your K is at 1. Therefore, it is at reset, so your Q is 0 and your Q naught is 1. But when you get over here on this rising clock edge, where clock is 1, set is equal to 0, but your J is now 1 and your K is now 0, so that symbolizes the set. So now your Q is equal to 1 and your Q naught is equal to 0. Here we are where J and K are both equal to 1. So now that symbolizes the toggle. And as you can see now, your Q is 0 and your 1 is, and your Q naught is 1. But at the same time, let's go back a bit. That's where it toggles, because now your J and K are still 1, but your Q is 1 and your Q naught is 0. So this represents the toggle between the two. We're doing my T flip-flop. So as you see, I have my code here. So with T flip-flop, I have my T, clock, reset, Q and Q out, Q naught. In the process, you use T, clock, and reset. So if reset is equal to 1, then Q is equal to 0, and Q naught is equal to 1. And on the clock event, clock is 1, and T is equal to 0, and Q is equal to Q, and Q naught is equal to not Q. And then on the other if statement, on the clock event, and clock is equal to 1, and T is equal to 1, then Q is equal to not Q, and not Q is equal to Q. So we go to the test bench, and you see we created a component with our T flip-flop. We created signals for each of the inputs and outputs, set them equal to 0. Created the port map. In the first process, your reset will be 1 for 50 nanoseconds, then switch to 0 for 500 nanoseconds. On the next process, your clock will be equal to 0 for 50 nanoseconds, and it will change to 1 in another 50 nanoseconds. On your main process, T is equal to 1, and you hold that for 100 nanoseconds, and then you wait, and then T goes to 0 for another 100 nanoseconds. So now we're going to go and compile. As you can see, 2 compiles with no errors. We're going to go to simulate. We're already simulating. So now I'm just going to go to the waveform. And as you can see, so when your T is 1, Q, when T is 1, you see that Q reset is on, so your Q is 0 and your Q naught is 1. But when the reset turns off, your T is 1, your clock is on, Q becomes Q, Q is equal to 1, and Q naught is equal to 0. And it will remain that way, even though your T and clock changes, your Q and Q naught will hold its value up until the clock and T change. Until the clock changes again, that's when your Q and Q naught will change. As you can see, it holds a value, and then on another clock change, and they change.